All right. Hello again, class. This will be now Unit 8, which is Radical Relationships and Rational Exponents. So at the beginning, it's going to look familiar to some stuff that I think you've seen earlier in the year, and definitely in Unit 6, you saw some of this. So 8.1a is Properties of Exponents. So right at the top here, product of a power. And to be clear, when we look at the product of a power, if we have 3 to the power of 2, 3 will be the base, and then 2 will be our exponent. So, product of a power, it works when we have the same base for the product here. So product of a power then would be x to the m times x to the n would be x to the m plus n. And so that should look a little familiar to what you've seen previously. Now with the quotient again, our bases are the same, but now we're dividing. So now for the quotient, we have x to the m minus n. So this I know we have seen in Unit 6. It may not look familiar right now, but if you have x to the third over x to the 2, or x squared, that's rewritten as x times x times x over x times x. So then you have these factors subtracted out. So that equals x to the first power. So then you have 3 minus 2 would be 1. Next we have power to a power. So in this case it's x to the m, and that whole quantity is then to the nth power. So now in this case it's going to be x to the m times n. The 0 exponent, so for x to the 0th power, that will then equal 1. So even if you have a really giant number like 41,000 to the 0th power, that will still equal 1. Our negative exponent, so this is where it is like our reciprocal. So x to the negative m, we want a positive exponent. So to make it positive, we rewrite it as 1 over x to the m. And so now it's in the denominator. The same thing would go for if you have 1 over x to the negative n. To make that positive, you would rewrite it now in the numerator, so x to the n over 1. That then changing where it's at here will make it now positive. So moving on for power to a product or quotient. So here we have a product of x times y, and the whole thing is to the mth power. So we're going to distribute that m through to each value, so that it's rewritten as x to the m times y to the m. And then for now division, it's x to the n over y to the mth power. You're going to distribute that to the top and to the bottom. So then you have x to the n times m. Since it was power to a power, it's going to be multiply over y to the m. So this is a very abstract way of showing you the different properties of exponents. So now we can get into some actual examples here for what those will look like. So first off, we have x to the 4th times x squared. So the bases are the same, and it's the product. So since it's the product, we're going to add those. So it'd be x to the 4th plus 2, and that equals x to the 6th. And when we write x to the 4th, that's x times x times x times x. And then there's this times symbol, the products, times x times x. So if we count them out, 1, 2, 3, 4, 5, there will be 6, and then that will simplify to x to the 6th. So now for number 2, we have x cubed to the 2nd power, so the whole quantity. So now we have a power to a power, so we're going to multiply x to the third times 2. So that's going to be x to the sixth. And x to the third squared can be written as x to the third times x to the third. So again, in this case, when we do x to the third times x to the third, that is x to the sixth. Because it'd be like 3x's and then another 3x's. So for this case, we have a product 3x, so times, so we're going to want to distribute that squared through. So it'd be 3 squared times x squared. So we can simplify 3 squared to 9x squared, because when we take the product, we can rewrite it as 9x squared. And just like the last problem, we can rewrite this as 3x times 3x. Then, because multiplication is commutative, you can reorganize this to be 3 times 3 times x. In this problem, same base, so the bases are both x, so we can use the quotient rule, which was x to the fifth minus 2, so that is x cubed, or we can write it out just to see, so it's x times x times x times x times x over x times x. So those simplify and these simplify, and we're left with x times x times x, which is x cubed. Alright, in this case, same base, and we have 3x cubed over x cubed. You might be tempted to call this 0, but let's do it the way where we say it's a quotient, so it's going to be x to the third minus 3, so that reduces to x to the 0, which is 1. And if we have x times x times x over x times x times x, those all reduce to 1, so all you're left with is 1 over 1, which is 1. So now in this case, you're going to have x to the third minus 5, so that equals x to the negative 2. So since we have a negative power here, we want it to be positive, so we're going to have to do that reciprocal where we get it in the denominator. So then it's 1 over x squared. And just showing you some extra ways to do it. If we have it like this, we have those 3 reduced, and then there's a 1, then it'd be 1 over x times x, which is 1 over x squared. So that's another way to get to that answer. Alright, example 3, it looks like we have a 3 to the fourth power squared, so it's a power to a power. So I'm going to rewrite that. Whoops. Look at all those open up. So now we have 3 to the fourth times 2. So that's 3 to the eighth. And I've solved this in my calculator. 3 to the eighth is 6,561. B here, so we have a quotient and the whole thing is to the third power, so we're going to distribute that to the top and the bottom. So when we rewrite this, it's 5 to the third power over 8 to the third power. You can't subtract the thirds because these bases aren't the same. They would both have to be 5 over 5. So now we can cube each value, and I've done this as well. So I have 125 over 512. In this case, now it's negative 2 to the negative third power times negative 2 to the ninth power, but we have the bases are the same. So since we have a product and our bases are the same, we could add them together, or we can do, since this is a negative exponent, we can put that then by doing the reciprocal. So we're going to want to do 1 over negative 2 cubed times negative 2 to the 9th power. So we can rewrite that as negative 2 to the 9th over negative 2 cubed. And actually, I'm going to keep that quantity like that. So now we can subtract, so it's negative 2 to the 9th minus 3. So that equals negative 2 to the 6th. And when we take negative 2 to the 6th, that will be, I'm pretty sure it's 64, but we can just double check. So since it's an even exponent, it would be the same as taking 2 to the 6th. So let's see here. We want 2. Where would it be? Oh man, I can't find anything. 2 times 2 times 2 times 2 times 2. That's the lamest way to do it. Okay, 64. So this equals 64. And there are a couple different ways you could have done it. You could have seen that it was negative 2 where the bases were the same, added those together, and already got to negative 2 to the 6th power. Evaluate each expression. All right, again, the bases aren't the same, so we can't subtract those exponents, but we can distribute this power here because it's a quotient to another power. So then we're rewriting that as a to the a squared times 3 over b to the negative 3 times 3. So that's rewritten as a to the 6th over, this is a multiplication symbol here, so it'd be b to the negative 9. So we're going to want that to be up in the numerator because it's negative. We want that to be positive. So we have a to the 6th times b to the 9th over 1. So then that would be our final answer because we can't simplify anything else here. All right, now in this case, we have a negative out front. So with a negative times y squared, it's a negative 1 times this value. So it's a product and we have it a power to a power. So we're going to have to distribute this 5 through here. So then we have negative 1 to the 5th times y squared times 5. And then we still have y squared and then y to the negative 12th here. These two values get brought down. So negative 1 to the 5th, that is going to be negative 1 times y to the 10th, because we took 2 times 5, times y squared times y to the negative 12th. Now, I'm going to add, because we have the same base, and since it's a product, we can add these exponents together. So this negative 1 is still up front. Then we have y to the 10th plus this squared value. So that would then be y to the 12th times y to the negative 12th. We can add those two together. So we have negative 1 times, these bases are the same and it's a product, so we can add those. 12 plus a negative 12 would be y to the 0th. So then that will reduce to 1. So our final answer is just going to be negative 1. For time here, I'm going to skip part C. So moving on to letter D here. We should notice again that it's a quotient and a product here to the 3rd power. So we're going to have to distribute that to each value here on the top and the bottom. And you could do a couple different steps if you wanted to. So you could reduce, you could bring the a to the negative 1st power up because it's negative, but I'm going to distribute that 3 through. So 1, 2, 3, whoops, 4, look at how bad that looks. I can't even see what my values were. So we're distributing that through, but I need to see what they were. So a squared times 3 times b, it'd be 1 times 3 over a to the 1 times 3 times b to the 5th times 3. So when we rewrite that, we have a to the 6th times b to the 3 over a to the negative 3 times b to the 15th. So now we have base over base, and it's a quotient, so we can subtract, and a base over base, and we can subtract. So for a to the 6th minus a negative 3, and then b to the 3rd minus 15. So when we rewrite that, this minus a negative becomes plus, so a to the 9th times b to the negative 12th. So we're going to want to bring that b back down. We have a to the 9th over b to the 12th. And then that's our final product here. Some more examples. So we have this product here, and it's all to the power of 2. So we're going to want to distribute that 2 through. Same with this 5 over here. We got to distribute it to each of the values that are being multiplied. So we have 3 squared times a to the negative 5 times 2 times b to the negative 2 times 2. I'm going to leave this second half, and I'm going to simplify this right now. So we have 3 squared, which is 9, times a to the negative 10th times b to the negative 4th. All right, now I'm going to bring this second part down and write it right here. So then we have times 2 to the 5th, and then a squared times 5, and then b to the negative 3 times 5. So we have 9 times a to the negative 10th times b to the negative 4th. It's pretty messy right now. Times 2 to the 5th, which would then be 32, a to the 10th times b to the negative 15th. Okay, so we're going to want to move stuff up and down, I think, because we have some negatives. So we have 9 times, well, actually, I'm going to bring down this negative and this one. So we have a to the 10th and then a b to the 4th. So I brought this one down, and this one down, and this one is negative, so times b to the 15th. The 32 stays on top, and then the a to the 10th stays on top. So 9 times 32 simplifies to 288. We have some bases in the numerator and denominator, so a to the 10th over a to the 10th will reduce. And then we want to add these bases in the bottom because it's a product, so over b to the 19th. So this will be our final answer here. Again, I'm reiterating, I want to overemphasize this. There's a couple different routes you can take when solving these. Okay, now in this problem here we have negative 2 times m to the negative 5th. So m to the negative 5th is its own thing. So we can bring that to the denominator. So I'm going to do that right away. Negative 2 over m to the 5th times, well, this one, it's a product, but it's to the 0th power. So we're going to distribute that 0 through. So times 4 to the 0th, and then we have m to the 4th times 0. Then we still have that 3m out front. So we have negative 2 over m to the 5th. This is two different problems here. 4 to the 0th will reduce to 1. M to the 4th times 0, that will reduce to m to the 0th, so that'll reduce to 1. And then we still have our 3m. So now we can multiply negative 2 times 1 times 1, that's still negative 2, times 3m would be negative 6m over m to the 5th. So then that will simplify to negative 6 over m to the 4th. Because if we subtracted m to the 1st minus 5 it'd be m to the negative fourth on top, and then we would have to bring it into the denominator. Whoops. So then it'd be over m to the fourth. So that's why m went in the denominator there. All right, so now this is going to look out of place, but it'll make sense in context once we get to these examples down here. So some review. Scientific notation is in the form c times base 10 to the power of n. And then c is going to be between 1 is inclusive, but less than 10. So strictly the integers from 1 to 9. So if you have something like 45, you need that integers, and it'd be 4.5. So actually, I'm kind of alluding to this problem right here. Also, if n is positive, it's positive n, we're going to shift things to the right. If n is negative, it's going to shift to the left. So let's make sense of that with this first example here. We have the super tiny fraction, and we want the integer between 1 and 9. So 45 is not what we want. We want 4.5. Now, so we can write that 4.5 times 10 to the, and we'll see what that is. And from this decimal, we're going to move left to this decimal. So since we're moving left, it's going to be a negative exponent. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So left, so it's a negative 12. In this next question, now it's going to be our digit from 1 to 9 is going to be 1 and then 0.39. So 1.39 times 10 to the, it looks like we're going to move to the right all the way to right there. So it's going to be to the right is going to be a positive exponent. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a positive 9. So for 1,390,000,000, scientific notation is 1.39 times 10 to the 9th power. That's how we can rewrite that. In this problem, now we have 3 as our digit, so 3.0 times 10 to the, looks like we're going to move right, 1, 2, 3, 4, 5, 6. So 3 million is rewritten as 3 times 10 to the 6th. We have 9.4 times 10 to the 1, 2, 3, 4. We moved left, so negative 4. Okay, so now they're asking us to rewrite it in decimal form. So this way we work to scientific notation. Now we're given scientific notation. We want to rewrite it in decimal form. So the decimal is here, and it's a positive 7. So we're going to go the way it's asking us to. So it's positive 7. So we have to go 7 units to the right. 1, 2, 3, 4, 5, 6, 7. So there's 2 zeros, and this decimal is now here. So this number is going to be really big. It's going to be 3 zeros, 27, 0, 0. So that looks like 40,002,700. So that's what this simplifies to in decimal form. This one is 9.6 times 10 to the negative 3. Negative, so left, 1, 2, 3. So this is the decimal, 2 zeros here. So what would that be? Tenths, hundredths, thousandths, 10 thousandths. It looks like 96 thousandths. So this number is now very small. 2.49 times 10 to the 5th. It's positive, so we're going to move to the right. So 1, 2, 3, 4, 5. So 0, so 2, 4, 9, 0, 0, 0. So 249,000 is what that one is rewritten as in decimal form. Okay, so now here's the application of how this relates to properties of exponents. We can take product of these, not integers, real numbers first. So we have 6, and since it's the product here, we can compute. So we have 6 times 2.4. So 2.4 times 6 is going to be 24, 12, 144. Move it back. So 14.4. So we have 14.4 times, now we have same base, and we have exponents here, and it's a product, so now we're going to add them. So 10 to the third times 10 to the fifth is going to be 10 to the eighth. But hold on, we have an integer that's greater than 9 here, so we're going to want to move the decimal here so that we have 1.44, because we want an integer from 1 to 9, times, so we moved left, it's going to seem backwards, we're going to want to add 1, so 10 to the 8th plus 1, so rewriting that, we have 1.44 times 10 to the 9th. It seems backwards, but since we moved to the left, we're going to need one more to rewrite it to go right to where that decimal would be in decimal form. So now in this case, we're going to want to, since it's the product here, to the third power, we're going to distribute that 3 through. So we have 3 cubed times 10 to the negative 4 times 3. So 3 cubed is 27 times 10 to the negative 12th. That decimal's here, so we need to move that right here. So we have that integer between, or from 1 to 9. So we have 2.7. Again, we move to the left, so times 10 to the negative 12 plus 1, because there's going to be, we're going to need one extra 1 to move to the right. So then we have 2.7 times 10 to the negative 11th. All right, one more problem here. So we have a product divided by a product. So again, in this case, we can take 5.4 divided by 7.2 first. And I've done that in my calculator, and it's 0.75. And then, since we will have a product over a product, so it'd be 10 to the negative 2 over 10 to the negative 8. We then subtract those, so 10 to the negative 2 minus a negative 8. So that's the same as negative 2 plus 8. So that equals 10 to the 6th. So now we have this times 10 to the 6th. Now in this case, to get to that digit or integer between 1 and 9, we have to move it to the right. So we have 7.5 times 10 to the 6 minus 1, because we need one more to go left, so minus 1. So then rewriting that, we have 7.5 times 10 to the 5th. All right, so those were the properties of exponents, and we related some scientific notation in. Hopefully you understood. If you have any questions, let me know. Email me or see me after.